We present our NoSQL Schema Management middleware Darwin. The name is alluding to Charles Darwin, the famous evolutionary scientist. In the NoSQL context, the database schema is flexible and thus suitable for an agile software development setting. Here the term schema evolution refers to the process of evolving the database schema during the development of a NoSQL-backed application. We're going to show the features of the Darwin middleware by example of a gaming application. Imagine that this game is developed in an agile setting, so typically the schema is altered many times. Because NoSQL database systems are often schemaless, schema changes have to be handled in the application code. As a consequence, developers need to deal with heterogeneous legacy data that is managed in the database. Let us take a closer look at the database of our gaming application example, where MongoDB is used, the popular document-oriented database management system. In a game, players play missions that take place at some location. Hence, the data structure has been defined by the types of player, mission, and place. Imagine that in the course of developing the game, it was decided to change the schema and add a maximum score to the type player, which was later renamed to max score, and this score was then copied to the type mission. Ultimately, the developers would like to have all data entities migrated to the latest schema in order to get a homogeneous database, which the application presupposes when querying the database. Now the features of our Darwin middleware come in handy, as the developers can get an overview of the existing schemas by stating the entity types that shall be inspected in an array of a JSON file. Such a JSON file is uploaded in the Schema Extraction tab, and upon selecting and executing Schema Overview, all specified entity types are presented with the properties of each entity type attribute in separate boxes, following a summary that states how many different versions per entity type exist in this database instance. As we saw earlier in the MongoDB database, the type player has evolved through 3 versions. In the description of the properties, it is also noted how often they occur. For example, the later renamed attribute maximum score still occurs in 20% of legacy entities of the type player. With our Darwin tool, we can save the schema overview as a JSON schema file at the bottom of the page for future reference. In a reverse engineering approach, we can now use Darwin to extract the schema versions. We select Initial Schema Version Extraction, click on Execute, and receive a complete list of schema evolution operations. In this list of extracted schema evolution operations, the users of Darwin are prompted to decide upon 2 alternatives of how the current schema has come about. As the developers are aware that it was decided to add a maximum score to the type player, which was later renamed to max score and then copied to the type mission, they can resolve the ambiguities by opting for the second options each and confirm the schema evolution operations to extract the current schema. Under Schema in the first tab, we can now see the extracted current schema, as well as its history, and neatly visualized div tables in other tabs. In case the developers want to limit the display to specific schema versions, the interval can be set by putting in version numbers. Here, for example, from schema version 16 to 17, which includes the copy operation of the max score property from player to mission. This added property is highlighted in green. Removed properties would appear in red. The Darwin tool also features the possibility of inspecting the heterogeneous entities of each type under database. We select the type player and can see immediately that the entity with ID 10 and namenet Stark has no maximum score attribute. The entity of player Arya Stark, on the other hand, still has the deprecated attribute maximum score. All other entities are according to the latest schema featuring the attribute max score. Now we can use Darwin to get our database instance in order and migrate all legacy entities according to the current schema. We switch to migration and determine which types and the extent of entities that will be migrated. We can choose either all of the entities or a limited prediction set. Under Operation Execution, we can specify whether the evolution operations are executed stepwise or optimized by combining them so as to save costs in case of extensive migrations. Also, the migration order and location can be specified, as well as other settings. For example, we can check the box schema cache for enabling caching in order to optimize the migration process further. We select the entity type player and leave the default values for all other options and hit Apply Migration. Once the migration is completed, we can check back with Database, select the type player, and find that now all entities carry the attribute max score according to the latest schema version, and consequently the player net_star shows a null value. One way to evolve the schema in Darwin is under Schema in the Evolution Operations tab. We click on Type Player again and can modify the schema as desired. For example, we mentioned that the schema of type Mission evolved to include max score from the type player. We can state here that the attribute values are copied in case that the player ID equals mission player ID. In case that the legacy entity shall be migrated, we can repeat the steps of the former chapter on how to handle heterogeneous data in Darwin. Thanks for watching. We hope you enjoyed this video. Go visit us online and try out Darwin yourself.